Hello and welcome to the second session in the Digital Leaders for Sustainability programme. My name is Mr. Bowl and I'm going to be leading this session with you, focusing around one of my favourite subjects, the hour of code and computer science. If you haven't had a chance to do our Canva Create Challenge, you can find it on the screen just above you and that link will take you back to do that. But when you're ready, let's have a go at creating our own sustainability project on Scratch. And the impact I'm looking for today is that you're going to develop this game, share it with other pupils, and you might even raise the profile of coding through bringing Hour of Code to other classrooms within the school. Let's go. So why the Hour of Code? Well, computer science is part of the computing curriculum, and it's digital leaders' role to help support and develop this within the school. This international celebration raises the profile of computer science. It helps children develop their creativity, but also our logical thinking, which helps us solve some of the world's biggest problems. Now, this event is going to happen on week commencing the 9th of December, and today I am going to be using Scratch and sharing a project from Raspberry Pi, all to do with their sustainability series. Let's get started then. Today's activity is on Scratch and it is a code along. I am using the resources from the Raspberry Pi Foundation Protect Our Planet series. I will link these, and if you want to, you could follow the 5 different activities, and also you'll have a description of how to follow the steps that I'll be sharing in this code along video. So what's our challenge? Our challenge is to use Scratch to learn about our planet and how to protect it for future generations. So our instructions today, the first step, you are going to navigate and create. You are going to follow the link to the starter project, remix it and prepare to code. If you have a Scratch account, you should be signing in so you can remix, save, then share. If you are a Scratch educator, if you're a teacher in your school, you could assign this through the class studio and then the children can remix from there in order to save the projects all in one place. So our instructions, after you've done that first thing, after you've remixed and signed in, it is time for you to go on to the next slide and then begin to follow my code along activity. I would suggest using this on your screen, maybe in the whole class, printing off the Hour of Code worksheet in front of you so you can have the instructions, the challenge ideas, the example, and you could also follow the link to the entire instructions from Raspberry Pi. So once you've followed the tutorial to complete your challenge, you can then further challenge yourself by adding power-ups to the game. Maybe you could create a different scoring system, more points for positive things, or make it easier, make it harder. You could turn it into a platformer by having levels, or I love the idea, why not turn it into a partner game, so multiplayer aspect. As always, final step, enhance your impact. Share the game with your peers, celebrate Hour of Code, maybe get into another classroom in your school and show and teach children how to code. Let's go then, on to the next task and ready to start coding. Task 2, follow along. You are going to watch my code along now to complete your project. Select the link there if you also want to have a written record of each of the steps I am following. Let's go. For those of you who have never used Scratch before, I have an area where I can see my simulation or my animation. I have an area where I can select sprites and change them. A backdrop area. This is my workspace where all of the code, the sequences that I create, or the algorithm will go. Then I have my coding palette. So this is where I pull all of my commands from, and you can see the selection is there in front of you. The first step in today's project is moving the shark. I've selected the shark sprite, and if I go to costumes, you can see that there are 2 different costumes. So I'm actually going to be swapping the costumes as we go to make it look like the shark is moving. I've pulled out the commands for you, but you can see by the colours, I have an event block, I've got 3 blocks from control, a repeat block and 2 conditional selectional blocks. I then, within motion, have like a reset block which sends me to specific coordinates, movement blocks. In looks I have some next costumes, and then I have some sensing in order to recognize the keyboard features, the keyboard keys I'm going to be using. Let's get started with the coding then. When the green arrow is selected, I want my sprite, my shark, to reset to this position. Then a forever loop, because everything I'm going to do with control, moving the shark, should happen throughout the game as soon as the event, the green flag, is selected. Then I'll have, if the left arrow is selected, then I want to move 10 steps. That would mean I move to the right. If it's the left arrow key, I need to move -10 on my coordinates. And I'm going to have next costume there as well. I'll slap that into my forever block, and then here's a really good top tip actually. I'll just duplicate it. Select that underneath, bring that all in, remove the unnecessary code, change this to +10 so it moves right, and change this to right arrow. When I press green flag, my shark should move from side to side using the arrow keys, and you can see that costume is changing. Now we have coded the shark to move from side to side using the arrow keys. It's time for us to generate the plastic, so the plastic will fall and the shark will avoid it. We will then move on to coding it, so when the shark touches the plastic, that would be a negative point, because that would affect the health of the shark. To start with then, to understand this concept, we are going to be using the plastic sprite, and we are going to generate multiple plastic sprites or multiple plastic clones at the top of our screen, which are then going to fall down the screen towards the shark for you to move out of the way. However, we only actually have 1 plastic sprite. So we are going to be creating a clone of this sprite in order to have lots across the top of the screen, all coded the same way to descend towards the shark. And then we're going to be using, in the looks button or the looks command, this hide block, and then the opposite for showing. So when we create the clone, we want it to hide at the top of the screen, and then when it descends towards the shark, we are going to get it to show. Otherwise your screen would be very busy and have a lot going on. If you've ever coded the Catch the Apples game in Scratch, or if you ever played something like Space Invaders, they're probably all built in exactly the same way. First thing then, on the green flag clicked event block, we are going to actually have the hide button, then go to, because this will make it go to a specific place, and then forever command, create a clone of myself, and then it's going to wait 1 second, but instead of waiting 1 second, it's going to wait and pick randomly between 1 to 3 seconds. That's going to create a clone and hide it, and now we can move on to making sure that clone descends down the page when we want it to show. Now we want the plastic to show, so we're going to select a costume, because we actually have 4 different costumes for the plastic. And then it's going to fall down the screen all the way to the bottom, and then it's going to disappear. For this, we're actually going to need to set a variable called speed. So I'm just going to do this now, make a variable, and I'm going to call this speed, and I'm actually going to apply it for this sprite only instead of for all sprites. And then I will just drag this in, so we have change my variable or set speed to pick random. So let's do that now and drop that to speed. Right, let's give this a go. When I start as clone, I'm going to show, Then I'm going to switch costume to pick a random, and because there's 4 costumes, I'm picking 1 to 4 costumes. Then I need to make sure that it just goes to a specific position across the top of my screen. So for this, on the x-axis, which is the horizontal line, I've got -200, which is the far left, all the way to 200 on the far right. And on the y-axis, I've got 200, which means it's going to sit right at the top of my screen. And then after that, we're going to have it so it falls down. After this block then, we are going to set speed to pick a random between -1 and -10. So this means the speed is going to change depending which of the clones it is. Then we will repeat this until the Y position is less than 180. So what this means is when the clone has been created, it's going to set a speed which moves it down the screen. It's going to repeat this until it gets to the Y position, which is -180. So let's change Y by -10, meaning it's going to go down at -10 each time. We've got repeat because it's going to move -10, then wait. And at the end of all of this, we want the clone actually to delete itself. So that means it's not going to be hogging up any space at the bottom of our screen. Let's have a quick go and see if this works. So you can see we're beginning to get these sprites falling from the top of the screen, and it is working because we're getting a variation of different costumes as well. Next part of my programming, I'm going to turn this into a game by making sure that when the plastic touches the shark, it's actually going to lose points. And I think this is what really makes a game as soon as you create a score. And in this case, my shark's going to have health points, and it has a way of the game ending or you winning the game. So in this case, when the plastic touches the shark, it's going to lose points, and then when you get to you lose all of your health points, the game is going to end. I could also, and in a moment after this, we'll create fish so you can positively score. But let's focus on the negative scoring to start with. I'm just going to hide this up here because I don't want to see that variable. Okay, let's create a new variable, and for this we are going to call it health. At the beginning of my game, I am going to set the health of the shark to 20. Let's press the green flag, and you can see that that has worked. Then what's going to happen, I'll bring into control if, and an operator, if the health of the shark is less than 50, it shouldn't be 50 actually, it should be 0, then I'm going to stop the game, and that will be like game over. That's when you might actually decide to have it to go to a game over screen. And I've added that to the forever loop. So now I have a set 20 health points. When it's less than 0, my game's going to finish and stop everything. But I need to make sure there's a way to negatively score. So here, underneath plastic, we're going to have when I start as clone, if I am actually going to be touching the shark, so I'll use the sensing button for this. Then I'm going to change the health by 5 points. Change health by -5. And if that's the case, then lastly, under control, I'm going to delete the clone, just like that. I'm going to test it. So if I touch this, it should be 5 points less. I've continued to play my game, and I've noticed that the health isn't actually going down. So I'm going to debug it, and I've just noticed it should be within a forever loop. So when you're touching it, it was just getting to the end of the code, it wasn't repeating itself. So now you can see that it's working, and if I get to 0, then it's going to stop the entire game. Right, let's change it so now I have a positive way of scoring. So I'm going to add a new sprite, and I'm going to use some fish for this. And you can see within the costumes there's a few different fish that play. So now I've got fish. Let's drag these up to the top. I'm actually just going to copy all of this code over to the fish. So you can see that that's come in from plastic, and then that has come in from plastic as well into fish. The fish look very, very big. So I think I might just change the size of these down to 40. The fish are now smaller, and I might just change it so the direction, we'll see if it's 180. So then the fish, it looks like they're swimming towards the shark instead. Now, you might have noticed that the variable here is going to change the health by -5. That wouldn't be correct. I need to make it positively scoring now. So if you're touching the shark, then it should be 1 point. Let's test it and see. So -5 if I'm touching the plastic, but we need to make sure that we are getting positive points if we are touching the fish. Now, if we just debug that again, you may have noticed that the fish aren't moving. So when I start as clone, show, and now it seems to be working. I know why that is. Because if we go to plastic and we zoom out, we have more code here. So we had it say the fish was going to create a clone of itself, but we did not have the generation through the green flag to actually create the sprite in the first place. So here we go, now the fish are moving. I've got 21 points because I've touched it, and now I can negatively score as well. What I would maybe think to do to end this is just maybe have a timer, so you run out 20 seconds and you see what the highest score is. So that should be your coding finished. It's all up to you to change it, and we're going to go back to looking at the slides. Then we'll look at some ways to challenge this activity even more. But great coding, there's a lot of blocks there. We've included selection, we've included repetition, we've got our conditional statements, the same as selection, and we have different events, and we've also included some variables. Great. So there we have it. Congratulations, you've created your Save the Shark Hour of Code project on Digital Leaders for Sustainability. And you can see my game playing up in the corner. Now let's add some challenge. So this means a way of improving our game and making it even better. So I said maybe a game over screen would be good. A timer would be another cool feature because that means it only plays for a certain amount of time to make it even more game-like. But here's some suggestions on the screen. Adding power-ups, so special items, kind of like when you're playing Mario Kart or something, which have different increased scoring. So maybe you get 1 point, maybe you get 5 points, whatever it might be. A scoring system, so maybe you could change that up even more with higher points, less points. You could turn it into a platformer. I love this idea. So if you copied your code over and you had 2 different backdrops, you could make everything move quicker in the next level. And in one level, it would be like if you get to 30 points, you move on to the next level. And that way, your game becomes a platformer. So it has increased difficulty. And the last one, very simple, but would be a feature, is could you add another sprite for the shark, use the WASD keys, and then can you play simultaneously? So have a go at those challenges, and we are then going to be ready to improve our impact. I hope you've got on well with some of those challenge activities. Task 4 then, improve, enhance, increase your impact. Share this game with your peers. Maybe you could challenge your teacher. Then maybe try and go to another class within your school and teach the children the hour of code and share the profile of computer science. I have another resource which I'm sharing, which has lots of activities that takes computer science all the way from reception up to year 6. And then maybe you could lead an hour of code assembly with the hashtag Digital Leaders for Sustainability. Great coding. See you next time.